Going to look at geometry 2. If you want to, you can have a look at any of the basic words to do with it. If you need me to explain any of them, that's fine. They give good examples down here of a converse, and they even talk about the word implies, which I assume you'll be okay with. We have different types of proofs that they're talking about here. So we have a direct proof. This is the most common form probably. So geometry is all direct proof. Proof by induction, that's the one that we just looked at. And then we're going to have a look at as well proof by contradiction. But this is the most common type. This is the one that you have been looking at junior cert. And you know, if I want to have someone expelled in the school, like I can't just go down to any principal or vice principal and say, right, so and so needs to be expelled. I have to be able to logically back up why I believe this. Now maybe that's a stupid example, I don't know, but I'm just trying to get the idea across. You could have a look here as well if you want at congruent triangles. I've talked about that in another video. It's just a reminder. And you just have to, you know, if you want to say that two things are equal, well, you have to give a reason why, usually a geometrical reason why. Or it could be an axiom, just a logical statement that we accept to be true. If you even have a look at the question that you had in your mock paper, it says in the diagram, C and D are parallel, CD is parallel to AB. So if you want to, you can put in your lines. What does that mean? Well, straight away, if I'm in a geometry question and they ask about parallel lines, I'll think, well, firstly, you know, basic parallel lines will never meet. They have the same slope. Maybe that would be more coordinate geometry, but all this stuff starts popping into my head. But specifically to geometry, I'm looking at alternate angles, possibly, if I can find the Z or the backwards Z, I have alternate angles, corresponding angles maybe. So that's straight away when they mention the word parallel. It says AC is perpendicular to AB. Well, that means to me 90 degrees. You know, I'll put in my 90 degrees, maybe consider Pythagoras' theorem, etc. as the question goes on. AB is 11 units, CD is 9 units, and AC is 12 units. Prove that the two triangles ABO and CDO are similar. So firstly, I need to know what the word similar means. It means they have the same size angles. Secondly, they have said prove. So if I tell you that this angle here is equal to this angle, I can't just make that statement. I have to back it up as to what geometrical, whether it's a theorem that I've studied or an axiom or whatever it is, I have to back it up. So what is it about those two that I know for sure make them equal? They're alternate angles. These two here are also equal. How do I know? Vertically opposite angles are equal. So that's a theorem you would have looked at in junior cert, so a proof that you would have looked at. Well, if that's the same as that and that's the same as that, well then these two have to be the same as each other. But if I wanted to, I could also say, well, those two are alternate. Either of those statements would work. Make sure that you express it correctly mathematically. So the measure of angle starting at B, going to O, ending at A, so the dot there, is equal to the measure of the angle starting at C, going to O, ending at D, so that one there. So those two are the ones that we're talking about. How do I know they're equal? They're vertically opposite angles. OAB is equal to OCD. ODC, sorry, not OCD, ODC. And the reason they're alternate angles. And then these two are equal to each other because they're alternate angles, or the remaining, as I said, the remaining angles of a triangle, the remaining angles of a triangle have to be equal. So these two triangles are definitely similar. Make a statement, back it up. Make a statement, back it up. Logical sequence of steps going on here with a backup every single time. So next 2 days, what you're going to do is you're going to have a look at exercise 10.2. Loads of proving to go on here. And you can have a look at 10.3 as well, if you're happy with your junior search theorems. Now what I mean by that is, do you remember the ones that you did? So the exterior angle is equal to the sum of the two interior opposite angles. Do you remember that in a parallelogram, opposite sides are equal and opposite angles are equal? So those two will be equal, so they're theorems. Just like what I said there, vertically opposite angles. That was the name of the theorem, vertically opposite angles are equal. That's the statement that I used to back up that the two angles were the same. This would be the statement you would use if you were trying to explain why these two are the same. Pythagoras' theorem, when you have a right angle triangle, consider that. And then the angle at the centre of a circle standing on an arc is twice the angle at any given point of the circle standing on the same arc. I wouldn't be surprised if some of you wanted me to go into detail on this, just because again you haven't seen it in a while, but the angle at the centre when you're standing on the same arc, so there's your arc, so you go from B to the centre to C, that angle there is going to be twice, start at B, go to any point on the circle this time and end at C. That proof has a few corollaries. So I don't mind going into detail if you want on that. Feel free to try as many as you want over the next few classes. I won't be putting up videos like for anything to do with geometry until you seem as though you're happy with this stuff. And then we'll probably do some constructions and questions to do with that.